Installation of HANA database on multiple hosts. You can say dual host installation. So all those things we'll see. Have a look at this first of all. Just adding one database here. So look at this database. So here it will show you clearly that this database is basically a distributed system. Yes, two hosts we have there. So all the memory, CPU, all the details is showing there. And if you go to the landscape, you can see we have all those services. What are the list of services we have? All of the services are available in HANA Test as well as on HANA Focus. Two hosts we have here. And those two hosts are shown here. This I'll explain you what is the significance of the terminology, what they are using there. Master, slave, that don't worry much. I'll explain you shortly. So here basically one single database HA6 is running on two hosts, multiple hosts. So you have compile server, daemon, index server, name server, preprocessor, start service. Web dispatcher and access engine is only one we have. So that's on the main host. Similarly, once you have the tables, now already this database is installed with a dual host, multi-host. So automatically when we have some tables created or imported, so they will be distributed by the system itself. So just to show you how it looks like, I'm just importing few tables, sample tables. So there may be some tables here which are already partitioned. So like this. A few tables like this. Look up, say, shop facts. And then we have something like outlet lookup. They're all just sample tables which I'm importing. So those tables are imported. Now we did not do anything, but automatically the distribution happens there. If you look at table distribution, right click here, there is an option show table distribution. And here you can observe that HANA Focus is there, HANA Test is there, some tables here, some tables. The same table you have partitions, multiple partitions. If you have multiple partitions, I'll show you some of the tables here, some of the partitions of the table here. Okay, if this partitioning concept is confusing, let me merge this. This table I'm putting it on a box. Now it's merged into one, so it's showing cross mark only. Showing numbers means so basically what is showing you is partitions. Now this table I'm merging and putting into this like that. Anyhow, I mean that decision we can take. We can move the tables from one host to another host. That flexibility always we have. See, two tables on HANA Folks, two tables on HANA Test we have here. Okay, so right at the beginning itself, if you have done an installation of multi-host database, then distribution takes place automatically. Don't worry about that. And you want to manually perform something, that facility is also available for you. But in case initially you started with a single host installation and later on, maybe after some time, because of your resources are very limited and memory is not sufficient, then after some time when you want to increase the memory, you have that facility of adding some additional host. Then you need to perform some manual activities. So those things also we'll discuss. Okay, so first of all, I'll show you how this database can be installed. This is already installed database, but anyhow, for your easy understanding, I'll show you an example of how to do that. Multi-host installation. Just follow these steps. I'll uninstall that and reinstall it. I'm uninstalling this one. We'll do a fresh installation. Another one more left over. Automatic uninstallation of remote host also, that also I'm doing. Okay, let us do installation. Normal procedure. Install server local host name. When it's asking do you want to add additional host, if you have multiple hosts, then say yes. I'm giving another host here. See, the preparation for this is, the most important thing is there must be a shared file system. File system must be common, shared file system. So when you're adding additional host, it's asking where you are adding that additional host as a worker or a standby, go with the worker option here. Scale out case, we use worker. Standby, when you want to go with auto failover scenarios, we use standby. So that also I'll show you one example. Remaining all the options are only in exceptional cases we use, like dynamic tiering, smart data streamings, and all that. So a worker means your database is distributed across multiple hosts. Failover is not required here. Storage partition system will take it. Worker group is something new what SAP has given. If you have many nodes, you can group them, otherwise not needed there. So now I'm just giving HA7 instance number 00, SD for single container. Even you can go with a multi-container also. Data volume location, log volume location. You observe that data volume, log volume is same, even though you have multiple hosts. I'll show you where the folders will differ. Certificate host name, both for local host as well as the additional host you are adding. And SID ADM password. System user password. Start the installation. So that will take few minutes, and in the meanwhile just try to understand the concept of scale out. When do we need exactly? See, the dual host installation or multi-host installation, the reason why they do it at the beginning itself is sometimes customers feel more comfortable using say two systems of 512 GB each than using one single system of 1 TB. And that way, maintaining those auto failovers also becomes easy for them. So in such cases, if they procure two appliances with 512 GB, you want to install HANA database with 1 TB, then this is what the procedure you need to follow, which we have started just now. So another situation is initially you started with 512 GB, later on after some time you want to upgrade to 1 TB, then it will be different again. That concept is different. So when you want to increase the configuration of your database, like your RAM and processors, you have two options there, scale up and scale out. So what you do in scale up scenario is you'll just increase the capacity of one host. One single machine is there, on that only you'll increase the capacity. Suppose if it is possible, you can upgrade it to the, say, suppose you have 512 GB. If it supports, you can go up to say 1 TB like that. And similarly, if you have dual processor sockets there, only one processor installed, you can get one more processor and install it like that. So that way you can increase the capacity of that host. But remember, in such cases, actually it's a pretty simple process, only hardware level you're doing it. Once you restart your system, automatically your database will be utilizing all those resources, provided there's no restriction you mentioned in the configuration parameters. So there's nothing you need to do there. There's a downtime, you stop the database, shut down the system, upgrade your hardware, and start the database. Only thing you need to verify is whether the license what you installed earlier is compatible for that increased RAM or not. Suppose you did an installation of license for 512 GB RAM, now you upgrade it to 1 TB. So there's no way you can utilize that RAM now. Definitely you need to increase the, as you increase the RAM, you need to get a new license also. And the new license key need to be installed. But when we speak about scale up, always there is a limitation. You can't exceed the limitations we have as far as that particular machine is concerned. Suppose if they're saying it's upgradable up to 512 GB, that's a limit. So when you want to overcome that limitation, then you can go with the scale out scenario where you'll increase the capacity by adding additional host. So multiple nodes like what we are doing now. After the installation, after some time you can do it. The basic purpose of that is to overcome the hardware limitation of a single physical server. So each of these hosts will have its own index server. And as I shown you just now, your different tables can be assigned to different hosts, which we call it as table distribution. And another option is also there. It's an optional one, not mandatory. One single table, generally when you have large tables with large volumes of data, you can split those tables, which we call them as partitions, and those partitions can be distributed across multiple hosts. So that's the facility you have. High availability, that is auto failover scenario. We'll see that. First, let us look into this practically, how these multi-host databases are working. Then once you have a clear understanding of that, I'll show you how that auto failover works. So here you can see that now it's already on the first host, your instance is created and it started the service and it's importing the delivery unit. Once this is done, it will add additional host. See now what's going on, adding additional host, showing that clearly. So I'll just connect to that 120. So this is actually a common shared storage /HANA. If if you look at this data, what we have installed now, HES7, you can see that here. And you can clearly observe the difference in this data volumes. Data volumes, if you look at this HES7, it's still going up. Let that over. Is actually common shared storage. Now you can see that HANA Fox is that additional host where your that instance is getting started. Same database, but there will be some services on that additional host also. So they're also getting started. So three things must be common, that slash HANA slash share, slash HANA slash data slash SID, slash HANA slash log slash SID. These three. They must be in the common shared storage. Should be mounted on all the hosts. That's a condition. And the system admins will do that very easily. So still some more services are getting started. It's HA7. Yeah, showing that distributed database here. So that's completed. The dual host installation, or you say multi-host installation, is done like this. So where it will show you like this. You can have a number of hosts like that. Okay. Now that's the case when at the beginning itself you have multiple appliances available and you're doing installation of your database with multiple hosts. Okay. Now let me remove this additional host. So I'm going to the platform lifecycle management. In that we have all these options available: adding host, removing host. So I'm clicking on remove host. And one most important thing is you're not allowed to remove the host directly here. Observe. If I try to remove this host HANA Fox, system doesn't allow you to do it because already we have some tables there. So when you have tables there, there's no way you're allowed to remove that. If you remove that host, it's not meaningful at all. That's why first of all, what we have to do is we need to prepare that particular host for removing the additional host. If you prepare the additional host for removing the host, then the data will be assigned to that another host we have there in that database. See, it doesn't allow the removal of the provided host. There is still data on the HANA Fox. So that's why whenever you want to remove the host, what you need to do is go to landscape. Here we have host. So this is HANA Fox. You can just right click on this. There's an option remove host. So just click on that remove host. Actually, it will perform reorganization. So on the extreme right, it's showing that removal status, reorganization started. What it does is it will move all the tables to that the remaining host what we left with the HANA test. So, and one more difference you can observe here in your data volumes, log volumes, you have this MNT001. 001 represents what? That host 1, this represents host 2. Every host will have that, right? Index servers and all that. So those access engine and the name server, like that. So that it will show you there. Those differences you can easily observe. Same you can find the log volumes also, like that. So the status what you can observe, reorganization finished. Once reorg is finished, now you can remove this host. Provide the host agent password, that is SAP ADM password. So that host removal is done, and now this database is a single host database. So again, go back here, refresh. You'll find only one host, and over here also you can see that It's not a distributed one now. Like, so you consider a situation where initially you started with 512 GB, later on they want to upgrade to 1 TB by adding additional host. The simple option is you can perform that by using this platform lifecycle management. But then what are the follow-up activities you need to perform will be different. So to understand those follow-up activities, see what I'm doing. Suppose assume that we started using this database with a single host, a lot of tables we imported or maybe replicated or maybe created, something we did like that. All this, these are all tables. I'm just, for your understanding, I'm taking. Now, if you go and look at this table distribution, you can find all these tables in one single host. Observe only one host, we have HANA test. There itself, we have all the tables and the partitions also, all the partitions. Okay, let me merge those partitions, no confusions there. Partitioning also, I'll show you how to do it. Now let us add that additional host as a worker only. So add host, a host agent password, SAP ADM password, SID ADM password, add host. As a worker or standby, two options you have. First, let us work with this worker for a scale out scenario. All the default options and click on next. It's taking so much of time. Okay, click on run. Now that additional host will be added. So because you're running this database for a long period, a lot of tables you have on one single host. Now, after this additional host is added, a lot of activities you need to do. One of them is the mandatory activity is immediately you need to distribute the tables across the multiple hosts. So that's done. Close this. Now you can see it's a distributed one. But now the question comes is if you see the table distribution still is showing everything on one host only, HANA test. So it doesn't make any sense. Even after adding additional host, if you keep everything on host one. So you have to distribute the tables properly. Okay, so to do that, the procedure you need to follow is this. Go to the landscape, your redistribution. So there's an option here, redistribute tables after adding host. So whenever you add additional host, this has to be done. Select that and click on execute. Automatically the plan will be prepared by the database itself. You don't need to do it manually because when you have thousands of tables, you can't specify simply which table should be on which host like that. System will take care of it. So redistribution, what is showing the plan? The only thing it's changing is only that show facts table. Remaining all want to still keep it on HANA test only. But this one will be moved from HANA test to HANA Force. That's what the plan system is preparing. Otherwise, you want to move some tables later on, you can do it manually. So just refresh. It's completed. Now let us go to the table distribution. You can see that shop facts table is moved to HANA Fox like this. Otherwise, your intention, like you have this table, this is a table. You want to move the table to HANA Folks, you can move it. Okay. Now it's running on HANA. Test will be moved to HANA Folks like that. So you can leave it to the system to do it, and afterwards, maybe one or two tables you want to move as per your requirements, you'll be able to do it. The reason why they'll give that option to you is sometimes, before adding additional host, the report was running fine. After adding additional host, it's giving performance issues because maybe that report is developed based on two tables. Earlier both the tables on one host you have, but now it's distributed to two different hosts. That may be the reason. So you can avoid that by getting it back to that single host. So that facility is also there. And another thing, as I mentioned, table partitions also you can perform when you have tables with a large volume of data. You'll be able to partition and distribute the partitions. That way also you can improve the performance. So which is generally recommended. So generally when you're doing searching, instead of a full table scan, it will go for scanning only a specific partition like that. So partitioning, if you want to perform for a table, remember basically there are two options for you. One, hash partition, and the one is range partition. Hash partition, what you do is just specify the number of partitions, that's it. Automatically system will distribute the data. See, look at this. I'm right clicking on this article lookup table, saying partition table. I'm choosing hash partition here. What I'm going with is number of partitions equal to number of hosts. Manual also you can give manual number. Now this table data will be partitioned into two. See that? But what you can see is both the partitions are on one host only. Maybe out of that one partition you want to move to a different host. You can just right click on this, move partitions. See how much flexibility we have here. So instead of just going with equal distribution, you can go with a range. Range like maybe your sales data from 2000 to 2005 one partition, 2006 to 2010 one partition, like that also you can give. So that kind of partition you want to have, just right click, partition table, choose range, click on next, select the partition column and define what are the partitions you want. Like I want to have partitions, one ranging from 1 to 100 and second partition from 100 is not included, so I'm giving 100 to 500 like this. Now in this case there will be three partitions, two partitions we define and one partition for those values which doesn't fall into this category. So there will be three partitions now. So out of these three partitions, one partition you want to move to another table, you can do it. So you can improve the performance with all these options you have. Whenever you remove the tables, remove the host, you go for optimize table distribution and partition, optimize table partitioning. Both of these you need to execute whenever you uh, remove the host, that additional host when you remove, otherwise not needed. Okay, so anyhow, as we have additional hosts here, I'll show you a simple backup option also here, how the backup works. Let's look at this. If I say backup system, complete data backup, see HANA test S3 we have HANA Folks index server is there. So because that will have its own data volume and log volumes. So it will take a backup of those files. And look at those files generated here. Still going on. So the backup is completed. So that index server we have additionally for that additional host you have there like that. So this way when you add additional host you need to deal with the system and distributing the tables, partitions and all that. Okay, so that's an example, and one example let us see for standby. So auto failover, how it works, I'll show you practically. So for that, first let us same host, we'll remove it and we'll add it again, but now this time we'll add it as a standby. So first I'm preparing that HANA Folks for removal. So reorg is finished. That's done. Now we'll add that additional host as a standby. Let us see whether that auto failover triggers or not. Add host. But this time we are considering this as a standby system. High availability groups you can give, otherwise default group it will take default. It's on run. That's completed. And that happens instantly because this just adding a host and that index server is not running there. It's just status you can see that ignore and is showing that the index server role is in standby mode now. So it's just standby mode. It doesn't have any data as such. The standby node doesn't have any data as such. But now what happens is in case your the node 1 goes down completely, this one, then the data volume of that will be assigned to node 2. So then you'll have that index server coming up with that particular data, whatever the data we have in that node 1. I'm just taking only two nodes here. Let us see really whether it, if I keep that node 1 down, whether this node 2 comes up or not. HANA test if it goes down, HANA folks should come up. So just for testing purpose, what I'm doing here is I can't shut down the system that HANA test. What I'm just doing is stopping the services on that. Only on HANA test I'm stopping the services. So you can see it's going down there on a test. Now for a limited time until this failover, auto failover is triggered and the second node comes up. Till that time, this database is not accessible to you. And I'm not doing anything. It's not like yesterday's case where in disaster recovery situation, we need to perform a takeover. Here, automatically it happens. So I'm not doing anything. We'll just wait for a couple of minutes and then let us see how this changes. How your standby node comes up with the data of this failed node. Standby node comes up with the data of the failed node. That should happen automatically. That's what we call it as auto failure. And just refreshes. So when you have three or more nodes, then it becomes easy for you to understand. One standby, if you keep it, one of the node goes down, the standby comes up automatically. Still, the system is accessible because here we have only one worker node, one standby. As worker went down, the standby has to come up. So that will take a little bit of time. See that? Which is running HANA test went down, now HANA folks came up. It's still starting. That will come up. See, HANA folks came up. Now your database is working as usual. HANA test is no, it went down now. Is this worker is a standby or still it's working now? It is acting as a master now, and this became standby now. So if this goes down, this comes up because I mean once your host is ready, and that comes up automatically. So that's how the auto failover triggers. What actually happens is you have this master name server. This master name server keeps on pinging the slave nodes to verify whether the daemon and two things, only daemon and name server are responding or not. If both of these are not responding, it triggers a failover. Not any one of them, both. One service fails, no, it won't trigger a failover. But if both are not responding, it triggers a failover. That's what you can observe here. I intentionally stopped, but in the company, you can say that system has crashed or something went wrong there. So once it comes up, and then you can, and if this you keep it down, it comes up automatically. Otherwise, let it run like this, and that whichever the node failed and it comes up, that will act as a standby. Okay, so this is the concept of additional host, how to add, how to remove, standby situation, how it works, worker situation, how it works, and all. So there are small terminologies which you need to understand, like what is that meaning of actual and configured one, why they use the terms. So that I'll explain in the next session. Monday that one, and whatever that system replication concept, those couple of parameters, operation mode and replication modes, those things also I'll explain. So because these topics are some specific exclusive topics which you can't do it daily, that's why I've covered it now.